When you have 50 mutations in a virus, you may get some gain of function, but you could also get some loss of function. And it is possible this particular strain may be less virulent rather than more virulent.
Welcome to the RANE Insights on COVID-19 podcast. I'm Emily Donahue. Let's listen as RANE founder David Lawrence speaks with Drs. Fred Southwick and Bill Lang for our weekly coronavirus update.
Bill, Fred, thanks so much for agreeing to do a special edition of our podcast, and thought it was important because over the long Thanksgiving weekend, new revelations came out about a new variant. And I know it's early, but nonetheless, you guys have been looking at the data. And let me take a step back and just leave it to you two to maybe tell us what we should know, what we should be looking at, and how to begin to think about this new variant.
I think the biggest thing is, like anything new that has potential to be have bad outcomes, the media jumps on it and focuses on all of the potential bad things. Those are all, you can't say that, no, there's no possibility that those potential bad things are out there. But the reality is it's probably not as bad as is being portrayed in much of the media. So rather than listen to all these possibilities, we really should start getting down to some facts about what we do know, not what it could represent in the future.
Yeah, I agree with Bill. It was quite frightening to learn about this variant, but the data is very, very preliminary. I think one of the key points is that this particular variant has more mutations in it than anyone described before. Approximately 50 mutations and 30 mutations actually in the spike protein itself. Now, a lot of them are clustered near the ACE2 binding site. And the theory is that theoretically, those mutations have allowed this variant to bind more tightly to ACE2 receptors. There are also some mutations in the furin cleavage site, which is when that site is cut, the virus is able to be internalized more rapidly. And so the fact that there are furin mutations and ACE2 binding mutations would predict that this virus would enter cells more quickly and more efficiently.
And so building on that, there was some initial information out of South Africa that this had almost completely displaced Delta in just a 2-week period, being first recognized in South Africa. Now we know since this initial statement that it was probably present much longer than that. But since first being recognized somewhere around the weekend of the 11th through 14th of November, it has, by estimate, not by direct measure, but by estimate, become the dominant strain in South Africa. So that implies, if that is true, and that is a question, that implies that this is a more infectious variant than Delta.
Yeah, I agree with Bill, but it's a very small area, and what can happen is you can, in a crowded area, the reproductive rate can look very, very high, and therefore it may appear as though it's spreading very rapidly. It's of interest that there are cases in the Netherlands, and and apparently about the same time it showed up there, so that it's possible that its reproductive rate is not as high. And only time will tell whether it truly is going to become the dominant. If it is, that is very worrisome.
Yeah, there's been one estimate, and the only estimate I've seen of reproductive rate came out of Israel, and they said that right now they believe it has a reproductive rate of around 2. But they had freely admitted there's not a whole lot of data to back that up.
That's what I saw too, and that's the reproductive rate of the original virus. So that would not be worrisome at all, in that Delta is 5 to 8, so it should remain the dominant. The other concern is because there are so many mutations, the conformation or the tertiary structure of the virus itself will have changed. And so when it changes and folds in a different way, epitopes that are antibodies that were induced by the vaccines that identify specific amino acid epitopes might be shielded, in other words, covered up. And therefore, the vaccine would be predicted that vaccine protection will not be as effective because of this extreme number of mutations within the virus.
But we're not really going to know whether that is true. I mean, that is clearly a very viable theory, but we're not going to know that's true until we actually start seeing epidemiologic data. Or over the next 2 weeks, virologists around the world are going to be growing copies of this virus and then subjecting it to sera, the blood samples drawn from people with various degrees of immunity from various sources and non-immune people, and seeing what the antibody response is to this new variant. That's going to take about 2 weeks until we have pretty good data on that. At least that's, as a non-virologist, that's what I understand is the typical timeline from this point.
Yes, that's right. They create a pseudovirus, and then they look at its killing with different dilutions of serum from individuals who have been vaccinated with the various vaccines. And then the amount you can dilute out that serum and still kill is the neutralizing titer. And it would be very interesting, for example, the Delta, particularly for the J&J and the AstraZeneca, particularly J&J, it dropped down to a 1-to-30 dilution, which is very low, compared to 1 to 1,200, which a lot of with the wild type of virus were the neutralizing titers. So in some cases, if you get down to 1 to 30, your vaccine is not going to be very effective.
But this will have laboratory-based research estimates of effectiveness of vaccines and, importantly, natural immunity. That's the other component that we have no idea right now on. So both of those are going to take about 2 weeks, doing it from a clinical epidemiologic point of view, and then from a bench research laboratorian point of view.
Yeah, and then the third concern is this particular strain more virulent, or does it cause more severe disease? I saw a little report by one practitioner in South Africa taking care of a group of people who reported that none of them lost their taste and sense of taste and smell, and suggested that maybe this particular variant might not be as virulent. Virulence is very hard to determine and takes a long time. For example, really there hasn't been any significant difference detected between the original strain, the alpha, the beta, or the delta variants. They all seem to be about equally effective at causing disease. But there is the more I've thought about this, when you have 50 mutations in a virus, you may get some gain of function, but you could also get some loss of function. And it is possible this particular strain may be less virulent rather than more virulent.
There's really three components for the non-infectious disease, non-virologist. My viewpoint is there are three things you need to think about with a virus. One is its virulence. How effectively does it cause disease? Its infectivity. How effective can it spread from person to person? And its resistance to vaccines. If we look at those three things, the change, all these mutations on this can affect each one of those three things differently. Because you could have a mutation that causes it to bind more readily, for example. And if it binds more readily, which is what this may have, then it may be able to reproduce itself more easily. But by the same token, some of these other mutations may cause it not to create as much inflammation as the original and the mutations that we know of concern. It may not cause as much disease as that. And then The third factor is that the way antibodies and then by extension the vaccines work is by actually having geometric, almost lock and key type of attachment to each other. And if any of these mutations affect the way that the current vaccines create antibodies that attach in this lock and key function, then you can decrease the effectiveness of the vaccine. There are relations between these three different components, but they can also be unrelated because they could be based on different mutations in different parts of the virus. So now I'll turn to the infectious disease person and see if I said that relatively accurately.
I absolutely agree. That was a really nice description, Bill. The three could be different, and I think we await the studies. The original fear, there was really original great fear, and still there is a little, because the one worry for me is if you look at the curve, the infection curve over time, the number of cases over time, you'll see that South Africa was very, very low, and then around November 20th, it shot up, and the steepness of the curve is like nothing I've ever seen. It was straight up. There was no exponential curve. It just abruptly rose. So that does suggest that the reproductive rate is high, or it is also possible it was in a crowded environment with individuals that were not using masks and were staying in closed environments in large populations. And apparently most of the cases early on have been in young people who tend to be socialized in larger groups and therefore would spread it very, very quickly.
So what was interesting about that is where the initial outbreak was noted was at probably the primary international university in Pretoria, South Africa, one of the capitals of South Africa. The other thing that was reported coming out of South Africa is even in the areas where they are having this very rapid increase in the case counts, as Fred has noted, they are not seeing a corresponding increase in the number of hospitalizations. Hospitalizations have roughly doubled, but the number of physicians in South Africa attribute this to whenever there's a new variant, there is a significant degree of fear. People present earlier for care, plus clinicians not knowing what the potential outcomes are going to be with a new variant tend to have a lower threshold for hospitalizing at-risk people until they know how this variant is going to affect them. The exact same pattern was seen with previous variants in South Africa.
One thing that we have not talked about, which I think we really need to emphasize, is that in South Africa, the percent vaccination, I think, was about 30%, 30 to 40%. And it just emphasizes how important it is that we get the vaccine to all countries as quickly as possible. If we're only as safe as our weakest link, and right now there are a lot of weak links, and it behooves the wealthier countries to provide vaccine for the countries that don't have the same resources, or this pandemic is never ending.
Yeah, well, actually, Fred, let me adjust downward. The vaccination rate in South Africa is actually 25%, at least as of this morning. And one of the issues that they are facing is basically a lack of popular support for the vaccine, people wanting voluntarily to take the vaccine. So the challenge is there may be some supply issues, but there's certainly similar, what I'll refer to as either educational or cultural barriers to agreeing to be vaccinated. So that continues to be a problem. And what I'm hearing from both of you is that there's a lot yet to be learned. There is a lot of data that we don't yet have. With all the information yet to come, what are you advising people and institutions in terms of reopening, in terms of travel, in terms of the types of gatherings that are often necessary for business, no less the social season that we're in the middle of?
Well, I've spent the last 2 days addressing exactly those questions. And the biggest thing I'm saying is I would be very concerned about planning any significant international travel right now. It's not so much because of a fear of where we stand with the Omicron variant, but it's a fear of how governments around the world are reacting. You can easily find stories of many people who, even in one case, people were on a plane to fly home, and the plane got the word that they were denied landing rights because they were coming out of southern Africa. So what could happen, how governments are going to react to this with various types of quarantine, isolation, and bar to entry orders would keep me from flying, at least for the next couple of weeks. That period of time that we said we need to get the epidemiologic and the bench research on this, I'd be uncomfortable with that. I am not advising significant changes in policies regarding return to office, masking policies, and any of that right yet. I think we still have time. We can watch a little bit what's happening. This is not going to be suddenly it's everywhere in the United States. There will be, it will have some ramp up period. Even the original strain had some ramp up period. And we can I believe that we can, if we start to see it emerge, we can turn on requirements as needed. But we don't need to jump to those right out of the gate.
One really important thing is don't loosen your policies right now any further than they are. I sort of think about sports and athletics. You would train for a sport and you'd get very careful in the way that you did certain techniques. And then if you don't have your coach around, you get sloppy after a while, and then you get into bad habits, and then you start to lose your athletic skill. Well, similarly, if we drop all masks, drop all of these different infection control practices, people will stay lax. And then if we need to ramp up, it'll be very hard to do. So do not ease up anything right now. Just give it a pause until we can find out more about this particular variant. That would be my recommendation.
Yeah, Fred, I agree completely. And in fact, that's exactly, as you know, I do some consulting with sports leagues, and that's exactly what I said. We don't need to reinstate certain testing and other procedures, but this is not the point at which we want to back off on anything. Let's wait and see. Yeah,
one other interesting thing that we did mention is this particular variant has a loss of a gene that's in one of the PCR detection kits. And so there are usually, when you use PCR, you usually actually try to have 3 different sets of probes. And they have one to the nuclear capsid, and they have one to the spike protein in this one PCR. And that particular sequence is missing in this variant. And therefore, if you have a positive for the other 2 signals and a negative for the spike protein, you actually can make the diagnosis of this variant without having to do full genomic sequencing. This is a big advantage and will allow us to identify the variant more quickly.
What is interesting, and this has been highlighted in prior podcasts, the pandemic is not just a biological issue. It's certainly political, it's psychological. And as you're both alluding to this, governments have taken very swift action to close their borders, and the markets are certainly responding, or gyrating, maybe a better term, to whatever the latest news is. And just curious, as some of the leadership out of both Moderna and Pfizer have commented, sort of you have your views on what the 2 most prominent vaccine manufacturers seem to be telling people in the markets about this variant, and anything that I'm not saying that the news is accurately covering it, but I know that you're monitoring what leading medical experts are saying and scientists are saying. But how do you interpret any of the messages that seem to be coming from the pharmaceutical industry about the variant, about the efficacy of current vaccines, about what might be developed down the road, and how people need to think about this?
Well, I think this is one of the most important features of the mRNA vaccines. And as I understand it, also they share this feature with the Novavax type vaccine, in that they can take the basic platform that they've used to develop the mRNA vaccine on the Novavax, and just fairly simply take out the current genome and put the new genome in, and then send it to manufacturing. There is some testing that needs to be done, but it is nowhere near the extensive testing that was done with the original. So it's a process that take from a decision to field a new vaccine based on a new variant. The decision it's about 2 months until you have a vaccine ready to start going into arms. That's a pretty quick process. So both Pfizer and Moderna, as well as Novavax, has said that they can do that very quickly. They're ready to make a decision. They did the same process with Delta, but then a scientific decision was made in conjunction with both the manufacturers and the major regulators around the world, that if they were to put out a new Delta-oriented vaccine, that what that would do is stop all vaccines until they had the new one ready, because people would not get the old vaccine if they knew they could get the new one.
Yes, and it turned out that if you get a booster, you're protected from hospitalization and serious disease in most situations with the conventional vaccines. I did hear today that the head of Moderna felt that this particular virus would escape the vaccines more readily than previous variants.
But we have heard that before, and it didn't turn out to happen. But not that the virus that was out there, the variant that was out there, could not escape, but that the variant did not become widespread. And that gets back to those three features: virulence, effectiveness, or responsivity to vaccine, and infectivity. And those are those three closely related but different characteristics.
Exactly. And, we've discovered there are a fair number of cases in the Netherlands, and yet there don't seem to have been huge outbreaks of this variant yet there. But we have very little data, so it may not be as dangerous or as widespread as we originally thought. I was never worried about the beta variant or the P1 and the Brazilian variant because they did not have a high reproductive rate. I think the key will be the reproductive rate as well as the severity of illness. Those two key are really going to be important.
Okay, and Fred, when you refer to severity of illness, the bar that I think you're addressing here, just to level set this, is hospitalization, correct?
Hospitalization, yes.
Okay.
Both.
I know that from our prior podcasts and our conversations that data coming out of Israel has been particularly important as a barometer of what may lie ahead and what might be required in response. Is there anything coming out of Israel or any other jurisdiction for that matter that you find to be a sort of a important indicator to keep an eye on?
Well, that, as we said earlier, the data about the reproductive rate of 2, that came out of Israel. I'm going to be looking for the Israeli data because they have excellent public health and laboratory science systems, and they traditionally have a significant amount of travel between Israel and South Africa. So it would be very, very reasonable to believe that if it's widespread in South Africa, it's likely going to be quickly widespread in Israel. So the effect of this variant on Israel goes is going to be very telling for how it goes for the rest of the world.
Okay, not just the rate of infection. I assume you're going to be looking closely at the severity and, as Fred was alluding to, the number of cases that result in hospitalizations, and to the extent that there are people who have been fully vaccinated, received boosters, how that data might compare to people who have not been vaccinated.
That's exactly right. The other thing that's going to be very interesting about this is if we look at, to the extent that we can, we look at the historical pathway that viruses have gone. Specifically going back to the 1500s in Europe, there was the sweating illness that many historical virologists, I'm sure there's a name for that, believe was probably a coronavirus. And it ended by petering out, and that the disease itself changed to not be severe. It was not this high fever illness that killed people. It became an illness that people got, and then eventually this has probably become one of the coronaviruses that is the causes the common cold today. The general pressure of evolution is to push a virus to be more infectious, but possibly even less virulent, because the way you get the greatest spread, which is what evolution pushes something to do, is by reproducing highly but not killing your host, so that your host can continue to reproduce.
That's really a nice analogy, Bill. I really like that, and it's exactly true. And the hope is, and that's what I'm starting to think now, because it has so many mutations in it, this virus may be less virulent. And if that's true, that would be a real silver lining to this whole development.
I love the process that the virus almost has a mind of its own. It wants you to host it, but doesn't want to kill the host. And maybe you can just comment about, just sort of the state of the science now in the ability to isolate the DNA, to identify what's needed to create a new vaccine, and the speed at which we seem to be able to create one. Whether it gets approved as quickly is another matter, but the speed to market, and certainly maybe one of the shining lights that does come out of this particular tragedy.
Yeah, I would agree. I mean, we've been developing more and more efficient sequencing methodologies for decades, and now we can sequence this 32 kilobase virus very, very quickly. So we can pick up all the variations, and then with the mRNA, we can design a message that exactly reflects those variations and get it into, put it in a lipid, get it into somebody's arm very, very rapidly. And that's why I think the mRNA vaccine is a major, major step forward. And the safety, even though people keep trying to claim that it's causing serious side effects, they really haven't shown up. So it's very, very safe. It's very, very rapidly can be altered and varied depending on the conditions and new variants. So it's really been a win-win.
Bill, your closing thoughts, because I know you're talking to clients.
I think people were originally, we heard the first things coming out of this, and it scared people. I'm not trying to say that people should not be concerned, but concern doesn't mean that you panic. Concern means that you follow the data, you educate yourself on what's out there, you get good trusted resources that can help interpret what we're seeing and help advise you on way forward. Right now, we don't have a whole lot, and the more we are learning, it's not looking anywhere near as bad as the first highly charged news articles and news presentations came out to say. So take a deep breath and let's watch what happens.
I have to tell you that I was working in the emergency room yesterday, and I talked to a lot of the doctors, and they really, really don't want another surge. I'm telling you, everybody is so tired of this disease and the devastating nature of this infection. And the problem we have in Florida is our politicians don't have our back at all. So if this does turn out to be a virulent, rapidly spreading virus, I'm telling you, Florida's in big trouble.
Again, I can't thank you guys enough for not only sharing your scientific insights, but a great deal of common sense and a great deal of calm. That said, we're going to stay close to this one. I'll be talking to you guys before the next podcast, and obviously if something significant happens in the interim, we'll get that out quickly to the audience.
Thank you, David.
Thank you, David.
Dr. Bill Lang is an expert in public health responses to biological incidents, including pandemics. Dr. Fred Southwick is an infectious disease specialist at the University of Florida College of Medicine. Both doctors are part of the RANE Expert Network. Individuals and organizations turn to RANE for risk intelligence that cuts through the hype to focus on what they need to know, what to expect, and what to do. Sign up for our coronavirus solution. Visit us at ranenetwork.com. That's RANE network.com. I'm Emily Donahue. Thanks for listening.